Welcome to my channel. Today we are going to discuss about the multiple choice question and answer from the part classification of signals, especially even and odd signal and deterministic and random signal. So in the previous two videos, we discussed the MCQ from the first one standard signal. The second part is classification of signals, that is periodic and non-periodic and energy power signal. Okay. So today in this video, so we are going to discuss about the questions related even and odd signal and deterministic and random signal. Okay. So the first one, first question you see, which one of the following is used to check the continuous time signal is even? Okay. So you know the signals are classified into two type, even signal and odd signal. The even means it is called as a symmetric signal. Odd means it is called as an anti-symmetric signal. So the condition in order to check the continuous time signal is even. The condition is that x of t equal to x of minus t. Okay. So the original signal and x of minus t, it is a time reversed version. Okay. Time reversed version or folded signal. If the x of t and x of minus t both the thing are equal means we can say that that signal is a even signal. Okay. Then the next one, which one of the following is used to check the discrete time signal is even? Okay. So here the first two thing, this is x of t equal to x of minus t, x of t equal to minus x of minus t. This is for checking the continuous time signal. So you see the third and fourth, x of n equal to x of minus n. Okay, so this is the condition in order to check the discrete time signal is even. Okay, so if one signal it is even, it should satisfy the condition, the original signal x of n and folded version, the both answers it should be same. Okay, so this is the answer. Then which one of the following is used to check the continuous time signal is odd? Okay, odd or anti-symmetric. So the condition in order to check the signal is odd, it is this is continuous time. So x of t equal to minus x of minus t. That is, after taking time reversal, we have to multiply it with minus 1. Okay, so we have to take inverse, amplitude inverse also. So if x of t value and minus x of minus t value both are same means that signal is called as an odd signal. Similarly for discrete time, okay, which one of the following is used to check the discrete time signal is odd? So that is x of n is equal to minus x of minus n. This is the condition. Okay, so even means x of t equal to x of minus t. Odd means x of t equal to minus x of minus t. Then for a discrete signal, even means x of n equal to x of minus n. Odd means x of n equal to minus x of minus n. Okay, so these are all the conditions in order to check that is a even and odd signal. Okay, then the next question, if a number of even functions are added, the resultant sum is, okay, so for example, if you are adding two even functions means what is the that resultant sum is even function, odd function, either even or odd function, a mixture of odd and even function. Okay, so what is the thing means even function. So if you are adding two even function means the answer is that it is a even function only. Then the next one, if a number of odd functions are added means the resultant sum is odd function. Okay, so if you are adding number of odd function means we will get the answer as a odd function. If you are adding number of even function means the answer is a even function. Okay, that's the thing. Then what is the even component of a discrete time signal? Okay, so already you know that is each signal. Okay, either it is a continuous time signal or a discrete signal. Each signal it can be written as it consists of some even component as well as odd component. Okay, so the addition of even component and odd component we are calling it as a original signal. So in order to find out the even component, what is the formula means? The even component of discrete time signal. So you see the first thing, in the first thing x e of t. So e of t means that the t it is used for the continuous signal. So it is not an answer. Similarly, the second one is also The variable is t, so it is not a thing. So third and fourth, you see x e of n, x e of n. Okay, so in this, which one is correct means the C is a correct. The even component x e of n is calculated as that. It is a addition of x of n plus x of minus n divided by 2. Okay, so x of n plus x of minus n divided by 2. So we have to add original signal with the folded version, and you just divide by 2 means this gives the even component of the discrete signal. Okay, similarly if you are subtracting x of n, x of minus n divided by 2 means this is the odd component. So this is not a correct, this is the correct answer, x e of n. Okay, next, what is the even component of continuous time signal? So the even component of continuous time signal is, so instead of n in this formula, you just put a t. So x e of t, even component of the signal x of t equal to x of t plus x of minus t divided by 2. So this is the even component. Then what is the odd component of continuous time signal? So the odd component is calculated by the x o of t. Okay, so odd component is equal to, we have to subtract the folded signal from the original signal and we have to divide by 2. So x of t minus x of minus t divided by 2. This is said to be the odd component of the continuous time signal. Okay, then what is the odd component of discrete time signal? So the first one you see, we are adding x of t, x of minus t divided by 2. This is the even component. So this is wrong. That is and x of t minus x of minus t divided by t. It's a odd component, but it is for the continuous time signal. Okay, so here the question is, what is the odd component of discrete time signal? So this is the answer. So the odd component x o of n is calculated by x of n minus x of minus n divided by 2. So this is the odd component of the discrete time signal. Okay, then the next one, determine the odd component of the signal x of t equal to cos t plus sin t. Okay, so determine odd component of the given signal x of t equal to cos t plus sin t. So here the given signal consisting of two component. One is one cosine cos t, another one is sin t. So in that, which one is a odd component we have to find out. Okay, so in order to find out the odd component, already you know the formula. So what is the odd component formula? X o of t equal to x of t minus x of minus t divided by 2. So first you just write x of t. So what is the given x of t? Cos t plus sin t. Then minus of x of minus t. What is x of minus t? In the x of t expression, you just replace t by minus t. So minus cos of minus t minus sine of minus t. Okay, so cos of minus t, already you know it's a cos t, that is cos of minus theta, we can written as a cos theta. Then sine of minus theta, it can be written as a minus sine theta. So minus of minus, it is converted to plus. Okay, so cos t plus sine t minus cos t plus sine t. So here the cos t cancel. Then 2 times the sin t, it will come. So 2 sin t divided by 2. So 2 cancel. So the answer is sin t. Okay. So the odd component of the given signal is sin t. So in this two part, cos t and sin t, this sin t, it is a odd component. Then what about this cos t? It's a even component. If the question they are asking, you see in the next question, determine the even component of the signal. So by that the answer, it will come as a cos t. Okay, so here determine the odd component means it's a sin t. The second part, the sin t is the odd component. Okay, similarly you see the next question, determine the even component of the signal. Okay, for the same question. So if you want to find the even component, so the formula, you know, the x e of t is equal to x of t plus x of minus t divided by 2. So you just write first x of t. So what is x of t? Cos t plus sin t. Then plus x of minus t. So in the x of t expression, wherever the t is available, you just replace it with minus t. So cos minus t plus sin of minus t. So you know cos of minus t equal to plus cos t. Sin of minus t equal to minus sin t. Okay, divided by 2. So here the sin t cancelled. Then 2 times the cos t, it will come. So 2 cos t divided by 2. So 2 cancel. So we will get the answer is cos t. Okay, so which one is a even component in that signal? This cos t. This cos t is a even component. So where is the answer you see? So cos t. So this cos t is the answer. The next one is if the signal uh, that is sin t. Okay, so it's not a sin t, it's a signum. Okay, yes, gn signum of t, it is antisymmetric. Okay, yes, the signum of t, it is an antisymmetric. Okay, sorry, sin t. Okay, sin signal is the signum of t. It's the next question. So yes, the signal sin t is antisymmetric. So we can check either it is correct or not. Okay. So in order to check the signal is antisymmetric. What does mean by antisymmetric? Odd signal. The other name of odd signal, it is called as antisymmetric. So you see, a signal is said to be antisymmetric or odd when it satisfies the condition x of t equal to minus x of minus t. Okay. Minus x of minus t. So first one, so given that given signal x of t equal to sin t. So next we have to find out x of minus t. So what is x of minus t? Sine of minus t. So sine of minus theta we can written as a minus sin t. Okay. So from that this is so x of minus t value is minus sin t. So if you are multiplying the x of minus t with 1 minus 1 means we will get sin t. So it satisfies the condition x of t equal to minus x of minus t. Okay. So that's why the sine signal is an example for odd signal. Okay. So you see any sine signal of any frequency, sine omega naught t, sine 2 pi ft, sine 4 pi ft, sine ft, sine 4t, any type of sine signal, it is an antisymmetric signal. Okay. So yes. Okay. It's a odd signal. The example for odd signal is sinusoidal waveform, signum function. Okay, signum function. These are all the example for odd signal. Okay, so for even signal, cosine waveform, rectangular pulse, it's example for even signal. Okay, so that's also a question. So you see, determine whether the signal x of n equal to sine 2 pi n is odd, even, neither even nor odd, both a and b. Okay, so already from the previous question we can say that any type of sinusoidal waveform, okay, sine wave of any frequency, it's an example for odd signal. So here it's a discrete sine. Okay, it's a continuous sine signal, it's a discrete sine. Okay, so anyway this is the odd signal only. Okay, so we can verify it using the given condition. So the signal is said to be odd if it satisfy the condition x of n equal to minus x of minus n. Okay, this is the condition. So the x of n, what is the given question? X of n equal to sine 2 pi n. So from this we have to find out x of minus n. So if you are calculating x of minus n means sine of minus 2 pi n. What is sine of minus theta? It's a minus sine theta. Okay. Then this x of minus n, you just multiply with the minus means. So again we will get sine 2 pi n. So that's why it satisfies the condition x of n equal to minus x of minus n. Okay, so that's why the sine 2 pi n is a odd signal. Okay, if it is a continuous sinusoidal signal or a discrete sinusoidal signal, it's an example for odd function. Okay, similarly the cosine. Okay, continuous cosine or a discrete cosine is the example for even function. So you see the next problem. Determine whether the signal x of n equal to cos 2 pi n. So what is the given signal? It's a discrete cosine waveform. So this discrete cosine sequence, it is odd, even, neither even or odd, both a and b. Okay, so the cosine waveform, it is an example for even. Okay, so we can prove it. Okay, so you just see, you know the condition in order to verify it is a even or odd. Okay, so what is the condition in order to check the signal is even? X of n equal to x of minus n. What is the condition in order to check the signal is odd? X of n equal to minus x of minus n. So using this condition, we can verify any problem. Okay, so here, what is the given x of n? Cos 2 pi n. Okay, so from that, you just find x of minus n. So you replace the n by minus n. So cos of minus 2 pi n. What is cos of minus theta? It's a cos theta. Okay, so we will get the x of n and x of minus n value both are equal. Okay, so that's why the given signal, it is a even signal. Okay, so the cos 2 pi n, it's a even signal. Similarly, cos t, cos pi t, cos 2 pi t, a continuous cosine signal is also a even signal. Okay, even function. Then the next one, the function x of t is shown in the figure. So what is this function x of t? It's a signum function. Okay, even and odd part of unit functions are respectively. So the question is, we have to find even and odd part of unit step function in terms of this x of t. We have to find out. Okay, so here, what is the question? U of t, unit step function is given. So for this unit step function, we have to find even part and odd part. Okay, so how can you calculate the even part? Even part is calculated by x e of t equal to, even part is equal to x of t plus x of minus t divided by 2. Odd part is nothing but x of t minus x of minus t divided by 2. So we may calculate this even and odd part using the graphical method also. Okay, so here we may use the graphical method. So first you see, this is the u of t signal. Okay, this is the u of t signal. U of t means, you know, the u of t, the amplitude is 1 for the time 0 to infinity. Okay, what is the next thing? We have to take mirror image of this u of t. So if you are taking, that is u of minus t, we have to calculate. Okay, so u of minus t. So if you are calculating u of minus t, so how to draw u of minus t? That is the positive time value is swapped to negative, negative time value is swapped to positive. So here the folded signal, we will get the answer like this. Okay, so from the time minus infinity to 0, the amplitude is 1. For the time 0 to infinity, we will get the answer is 0. So this is the u of t, this is the u of minus t. Then if we want to find a even component means, first you just add these two signal. Okay, so you add u of t plus u of minus t. So you see u of t plus u of minus t. So if you are adding these two signal, we will get that is constantly 1. Okay, constant 1 for the time minus infinity to plus infinity. Constantly 1 it will come. This is the DC signal. Okay, then if you want to find the even part, this added signal you just divide by 2. So if you are dividing this DC signal divided by 2 means the amplitude 1, it is reduced to half. Okay, so that's why we will get this signal. Okay, this is the signal. So this is said to be the even component. So the even component is nothing but, so what is the even component obtained for this u of t? 1 by 2. Okay, so you see where is the even component? 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 2. So maybe A or C. Okay, this is the even component. So similarly, next we have to find out the odd component. Okay, so in order to calculate the odd component, we have to subtract. Okay, so you just subtract the second signal x of that is u of minus t from u of t. Okay, so u of t first signal minus second signal we have to subtract. Okay, so you just so this first signal minus second signal. So if you are subtracting, what is the data we will get? So here you see for the minus infinity to 0, what is the amplitude? Here 0, here 1. So 0 minus 1, what is the answer we will get? Minus 1 answer we will get. Okay, minus 1. Similarly for positive duration, here 1 is there, here 0 is there. So 1 minus 0, 1. Okay, so plus 1. So here 1, here minus 1 we will get. This is the u of t minus u of minus t. Then if you want to find the odd component, you just divide it by 2. So this amplitude, if you are dividing by 2 means we will get this minus 1 amplitude is reduced to minus 0.5 and 1 amplitude is reduced to 1 by 2. So here 1 by 2. So here minus 1 by 2. Okay. So you see what is the signal? The signal shape is like our given x of t. Okay, so that's why the odd component is nothing but half of x of t. Okay, so half of x of t. So where is the answer? So the answer you see the option A. Okay, the even component is constantly 1 by 2. the odd component we can obtain signum function, but amplitude is reduced to half. So 1 by 2 x of t. So this is the answer. So in this way we can calculate. So why you are using the graphical method means, so here the unit step function is given. If it is a mathematical function means we may use this mathematically we have to substitute. But in u of t, there is no mathematical form. It is having constantly 1. So that's why we have to use the graphical method. Okay. Then the next one, the unit step signal delayed by 2 seconds. Okay. So these topics are under that is operations on the signal. Okay. So we can perform different operations on the signal: amplitude scaling, time shifting, time scaling, and time delay and time advance, and so on. Okay, so in that thing, so here the unit step signal delayed by 2 seconds. So unit step signal means u of t. So delayed by 2 seconds means it can be represented as u of t minus 2. Unit step delayed by 2 seconds means minus 2 we have to put. Okay, then the unit step signal advanced by 2 seconds. So advanced by 2 seconds means that actual unit step signal, it starts with 0. Okay, and advanced by 2 seconds means that signal starts at a time t equal to minus 2. So that's why the signal, it can be represented as u of t plus 2. Okay, so u of t minus 2 means after 2 seconds only the unit step signal it will start. So it is a delayed signal, u of t minus 2. Advanced signal means u of t plus 2. Okay, this is the one. And the next one is a into u of t is the amplitude scaled version of unit step signal, time scaled version of unit step signal, time shifted signal, none of the above. A into u of t. Here u of t is the unit step. So the unit step amplitude is multiplied with some constant a. So that's why it is said to be the amplitude scaled version. Okay, amplitude scaling means the amplitude of the particular signal is increased by some scalar amount. Either it is a positive scalar or negative value. So it is the amplitude scaled version. Okay, so this one, this u of t minus 1, u of t plus 1, these two things, it is said to be the time shifted signal. Okay, the actual signal shifted by some amount. Then u of 2t, u of t minus 2, these two things is said to be the time scaling. That is, the time t is multiplied with some scalar value 2. Here the t is multiplied with the scalar value 1 by 2. So these two signals are called as time scaling signal. These two is called as time shifted signal. Here in time there is no change. The signal amplitude is multiplied by the scalar. So that's why it is said to be the amplitude scaled version. Okay, then the next one, a deterministic signal has uncertainty, no uncertainty, partially specified function of time, none of the above. Okay, so a deterministic signal, already you know, the deterministic signal means the signal is having, that is, the signal can be described either mathematical format or lookup table or graphical method. It is called as a deterministic signal. Okay, so the and random signal means, you know, the random signal, it cannot be described by any mathematical thing and so on. So the deterministic signal, it has no uncertainty. Okay, the example for the deterministic signal is all standard signal: unit step, impulse function, sinusoidal, this rectangular pulse, all standard signal we discussed. It is a this is the which signal? Deterministic signal. So noise generated by the signal, it is called as an example for random signal. Okay, so these questions are some of the questions from even and odd part. Okay, so that is the even, the example for even signal. You just remember that the examples for even signal is rectangular pulse. Okay, rectangular pulse is example for even signal. Then cosine waveform is an example for even signal. Then for odd signal, sinusoidal waveform, signum function. Okay, then sync pulse. Sync pulse is an example for even function. Okay, so these are all the things you just remember. Then if you are adding the even component and odd component, we will get the original signal. Okay, so we calculated, you see, the x e of t and x o of t. If you are adding the even and odd component, we will get the total signal x of t. So each signal x of t is having some even part and odd part. Okay, so if you are adding the two part, we will get the even component. Okay, for one even signal. Okay, so you note down these are the point. For one even signal, odd component is 0. Okay, if one signal is a even signal, odd component x o of t or x o of n is 0. If a signal is a odd signal, the even component is 0. Okay, for odd signal, even component is 0. Only odd part is available. For even signal, odd part is 0. Only even part is available. Okay, so these are all the some of the things about the this part. Okay, so in the next video, so we will discuss about the classification of system. Okay, from the classification of system, we will see the MCQ questions. Okay, so thanks for watching my channel. And please subscribe my channel for more videos and share this video to your friends also. So utilize this video to in order to score the good marks. Okay, so thank you.